Today we will learn the approaches of software design. There are two fundamentally different software design approaches, function-oriented and object-oriented. Though these two design approaches are radically different, they are complementary rather than competing techniques. The object-oriented approach is relatively newer technology and is still evolving day by day. For development of large programs, the object-oriented approach is becoming increasingly popular due to certain advantages that it offers. On the other hand, function-oriented design is a mature technology and has a large following. They have some salient features also. These two design approaches are complementary. We have already told that, and each technique is applicable. The system is looked upon as something that is perform a set of functions in a function-oriented design. In function-oriented design, the system is looked upon as sometimes that performs a set of functions. It is actually, and this is the salient features of the function-oriented approaches. The top-down decomposition is one type of function-oriented approach, where a system to start with is viewed as a black box that is provided certain services to the users to the system, and the top down it decomposes from the high level view to each high level function into some low level detailed function. Each function is refined into more detailed function by top down decomposition, and functions are mapped to a module structure. For example, if we have a function create new library member, then essentially we should create the record of a new member, assigns a unique membership number to him, and prints a bill towards his membership charge. So these high level function may be refined into some sub functions like create the record for a new member, assign the member unique membership ID, prints the bill towards the membership. Each of these sub-functions may be split into more detailed sub-function and so on. So this is one of approach of function-oriented design. In function-oriented design, the system state can be defined as the values of certain data items that determines the response of the system to a user action or external events. Member records, for example, the set of books. The book may be borrowed by different users or available for issues. It determines the state of library automation systems, such as data in procedural programs, usually have global scope and are shared by many modules. In library management system, several functions as the following share data structure as member records for reference and updation, like create new member, delete member, update member records, etc. Several function-oriented design approaches have been developed, like structured design, Jackson structured design, Warnier or methodology, Ritz stepwise refinement, Hatley and Purvey's methodology, etc. So here another example, the create library member function. We have already showed this example in previous slides. So move to the next. Object-oriented design approach. The system is viewed as a collection of objects or entities. Each object is associated with a set of functions that are called its method. Each object contains its own data and is responsible for managing it. The data internal to an object cannot be accessed directly by other objects, and only through invocation of the methods of the object. The state is decentralized since there is no global shared data in the system, and since there is no shared data in the system, and also see, the system and data is stored in each object. For example, in a library automation software, each library member may be separate object. Each library member may be separate object with its own data and functions to operate on the stored data. The methods defined for one object cannot directly refer to or change the data of other objects. This is the features of object-oriented design. But in function-oriented design, it cannot directly refer to the changed data to other objects. Functions defined for the one object. The object-oriented design paradigm makes extensive use of principle of abstraction, that is called abstraction and decomposition, as explained here. The objects decomposed a system into functionally independent modules. Objects can also be considered as instances of abstract data type. The abstract data type did not organize from the object-oriented approach. Okay, if actually the abstract data type in programming language, the abstract data type is the important concept that forms an important pillar of the object-oriented concept also. Now, actually, we should discuss some of the features of object-oriented design, like the data abstraction. Unlike function-oriented design, the principle of object-oriented design is to implement the data abstraction. That means how the data is exactly stored is an abstract way, and the entity external to that object would have no knowledge about how the data is exactly stored, organized, and manipulated into the object. And the entities external to the object can access this data, internal data, to of an object only by calling certain well-defined methods or functions supports by the object. If we consider a stack, which is an abstract data type example, the data of a stack object may internally be stored in an array or linearly linked list or a doubly linked list or bidirectional linked list. But the external entities have no knowledge of this and can access the data of a stack object only through the supported operations, such as they use push, pop, etc. In real-world entities such as employee picture, machine, radar system, etc., these are the real-world entities, example of real-world entities, and the short display track, etc., these are the functions. A data structure is considered from a collection of primitive data items, and the such as if we say a civil engineer builds a large civil engineering structure using primitive building materials such as bricks, iron, cements, etc. A programmer can construct a data structure as an organized collection of primitive data such as integer, floating point, etc. So these data structures are stored into some functions or some objects. Here the similar objects, each and every objects have his internal data structures which define the state of that object, and similar object constitutes a class. In other words, each object is a member of some class. Classes may inherit features from a superclass. Conceptually, objects communicate by message passing. Objects have their own internal data. Thus, an object may exist in different states depending the values of the internal data. In different states, an object may behave differently. So this is the conceptually the objects communicate by the message passing. Here are some different ideas, different object-oriented function and designs. Unlike the function-oriented design, the object-oriented design, the basic abstraction is not serviced available to the users of the system, such as issue book, display book details, find issue books, etc. But real-world entities such as member, book register, etc. For example, in an object-oriented example, an employee payroll software is not developed by designing the functions such as update employee record, get employee address, etc. But by designing the objects such as employee, departments are the example of this object-oriented versus object-oriented objects, example of objects in an object-oriented programming. In object-oriented programming design, the state information exists in the form of data distributed among several objects of the system. But in contrast, in a procedural design, the state information is available in a centralized shared data store. For example, while developing an employee payroll system, the employee data such as the name of employees, their code numbers, basic salaries, etc. are usually implemented as global data in a traditional programming system. Whereas in an object-oriented design, these data are distributed among different employee objects of the system. Objects communicated by each other by message passing. Therefore, one object may discover the state information of another object by sending a message to it. Of course, somewhere or other, the real-world functions must be implemented. Function-oriented techniques group functions together is a group, they constitute a higher level functions. On the other hand, object-oriented techniques group functions together on the basis of the data they operate on. Greedybuch sums up the fundamental difference and saying the identify verbs if you are after procedural design and nouns if you are after object-oriented design. So in object-oriented design, we uses some nouns like employees, departments, and in procedural or function-oriented design, we use verbs like update employee record, get employee addresses, etc. In object-oriented design, state information is not shared in a centralized data store, but it is distributed among the objects of the system. For example, And in an employee payroll system, the following can be global data: name of the employees, their code numbers, basic salaries, etc. But in object-oriented design, the data is distributed among different employee objects of the system. Objects communicated by message passing. One object communicates to each other. One object may discover the state information of another object by interprogramming it, or by sending the message and receiving the information. Of course, somewhere or other, the functions must be implemented. So what do you think, that objects, there is no necessary of functions? No. The functions are usually associated with specified real-world entities. So that means with the objects. They directly access only part of the system state information. These functions only access some part of the system state information. The function-oriented technique group functions together if, as a group, they constitute a higher level function. On the other hand, object-oriented techniques group functions together on the basis of the data they operate on. To illustrate the differences between object-oriented and function-oriented design approaches, let us consider an example. An automated fire alarm system for a large building. We need to develop a computerized fire alarm system for a large multi-story building. So what we will do, there are approximate 80 floors and 2000 rooms in the building. Different rooms for the building, and it fitted with smoke detectors and fire alarms. The fire alarms would monitor the status of these smoke detectors. Whenever a fire condition is reported by any of the smoke detectors, the fire alarm system should determine the location at which the fire has been sensed and then sound the alarms only in the neighboring locations. The fire alarm system should also flash an alarm message on the computer console. Firefighting personnel would man the console round the clock. After a fire condition has been successfully handled, the fire alarm system should support resting the alarms by the fire fighting personnel. So these are the features of fire alarm system. It should flash an alarm message on the computer console. The fire alarm system should let firefighting personnel reset the alarms. So if we approach the different high-level functions of the first, if we identify first, then the data structures are designed such a way that bool is the data structure for detector status, int detector location, bool for alarm status, int for alarm location, int for neighbor alarms. So these are the centralized data structure in a function-oriented approach. And the functions may be interrogate detectors, get detector location, determine neighbor, ring alarm, reset alarm, report fire locations, etc. So these functions are the approach in a fire function-oriented approaches. Now, in object-oriented approach, we have to find out the different classes of objects We have to identify it first. Subsequently, the methods and data of each object are identified, like the attributes here: status, location, neighbors. These are the attributes, and the operations are create, sense, status, get location, find neighbors. These are the operations of class detector. Then the class alarm is another class, and the attributes are location, status, and the operations are create, ring alarm, get location, reset alarm, etc. The appropriate number of instances of the class detectors and alarms are created. This approach is into the object-oriented approach. Now, if we compare the function-oriented and object-oriented approach based on these two examples, as we have discussed in previous two slides, and easily observe the following we can easily observe the following differences. In a function-oriented approach, the system state, that is the data, is centralized and several functions access and modify this central data. In case of an object-oriented program, the state information, that is the data, is distributed among various objects. In the object-oriented design, data is private in different objects, and these are not available to other objects for direct access of the modification. The basis unit of the design in an object-oriented program is object, whereas it is functions and modules in procedural designing. Objects appear as nouns in the problem description, whereas functions appear as verbs. So the structure is such a way that we use first the object-oriented design to the classes, then we apply some top-down function-oriented techniques, then we design the internal methods of the classes. These are the approaches we follow in an object-oriented programming. Though outwardly a system may appear to have been developed in an object-oriented fashion, but inside each class there is a small hierarchy of the functions designing in a top-down manner. So we must emphasize that it is not necessary that an object-oriented design be implemented by using an object-oriented language only. However, an object-oriented language such as C++, Java support the definition of all the basis mechanism of class like inheritance, objects, methods, encapsulation, etc. And also support all key object concepts that we have discussed already, or we know, which are available in object-oriented language. However, an object-oriented design can as well as be implemented using a conventional procedural language also, though it may require more effort to conventional procedural language. It may require more effort to implement it. Even though object-oriented and function-oriented techniques are remarkably different approaches to software design, yet one does not replace the other, but they complement each other in some senses. For example, usually one applies the top-down function-oriented techniques to design the internal methods of a class. Once the classes are identified, in this case, though outwardly the system appears to have been developed in an object-oriented fashion, but inside each class there may be a small hierarchy of function designed in a top-down manner. So we identified the two functional difference approaches of software design, function-oriented and object-oriented, and we have already discussed the essential thoughts governing these two approaches, and we have argued these two approaches of software design, and we say that the competing approaches by complementary approaches of these two methods also.